Okay, I'm going to show you a demonstration, and it's a shame that the board can't see it, but anyway. And in this demonstration, in one bottle here, I have some lead nitrate. Okay, so tell me, in this bottle of lead nitrate, what is it? Lead nitrate. What's inside the bottle? What would it dissociate into? What's in here? PB. Two pluses. And NO3 minuses floating around in that bottle. Everybody okay with that?
Are we drawing this now?
They are not together, they are separate. You don't need to draw it down. They're not together, they are separate. Or they're not, yes, that's what I mean.
Yes.
Okay, so that's what's in here. In another bottle, I have some potassium iodide. So what's in this potassium iodide? Is it potassium iodide? No, it's K pluses and I minuses. You okay with that? I'm going to take a scoop of each of these, or a droplet of each of these, and put them into my test tube. Okay? So here we go. Some potassium iodide in the test tube. Everybody okay with that? What does it look like? Water. Describe it for me, please.
Clear liquid.
It's clear, meaning it's not cloudy. It's a liquid. And what color is it?
Transparent.
Clear.
No, that's the light passing through it. That's what color? Colorless.
Colorless.
Okay? Can't say clear. Clear is the opposite. Oh, it is clear. But you could have blue clear things or orange clear things. It just means it's not cloudy. Okay? So it is clear, but it's also colorless. And the lead nitrate, describe it.
Same.
Looks the same.
Same. So therefore describe it.
Colorless.
Colorless.
Liquid.
Liquid.
Clear, colorless liquid.
Now I'm going to put them together. So two clear colorless liquids, put them together, and what do I get?
I swear I saw some yellow.
Cloudy yellow.
Really? Cloudy yellow liquid.
Right. Okay. What I've formed is a precipitate. I've formed a solid. And if I can do this just a little bit, sometimes you can get some that's just stuck. See, can you see now it's solid on the top?
Yeah.
Can you see that that's a solid? So a yellow solid has formed. Do you know what it's called when you get a solid formed from two solutions? A precipitate. No, just precipitate. Okay?
Two things.
So, the reaction in Science 10, you would have written in lead nitrate, so PbNO3, and potassium iodide went together and formed a precipitate, which you probably would have looked up on your data booklet. I'll tell you the precipitate was lead iodide. And the other thing that formed was potassium nitrate because it is a double replacement reaction. Okay? So far that's Science 10. Maybe that being a solid precipitate might be new to some of you, but it's supposed to be Science 10 review. This is aqueous, but I can't get the aqueous in there. This is aqueous. This is aqueous. Spencer, question?
So, like nitrate, that's one. Why wouldn't you put brackets around it? And sometimes you do.
Because if I need two of them, I need to put brackets around it. If I don't
You
have,
just. Okay.
if I don't need two of them, or three or four, I don't have brackets. So what's the picture then in my test tube? What's going on in my test tube? So you told me that this PbNO3 dissociated into Pb2 pluses and NO3 minuses, right? That's the dissociation equation that you would have written on the last sheet. That gave me that plus that. Agree, nod your head, disagree, shake your head, don't know, shrug your shoulders, so I can say that a different way. Okay, everybody okay with that? On the last sheet you would have said that. And so that's why you told me that picture exists there. And this picture exists like this. So what's happening in the test tube?
They're
coming together.
the lead iodide is like stuck to the thing because it's the solid precipitate.
What's stuck to what thing?
Well, I don't know if it's stuck, but that's what the chunks are. That's the precipitate.
Okay, that's a solid. Good. Okay, so here's some solid. There you go. There's some solid within my solution. And in fact, actually, if I wait long enough, all those solids are going to settle to the bottom. Okay? I've got ions and symbols. You've got circles. What's it going to look like in the test tube?
Yellow.
PBI2 and then.
Where's my...
on the bottom.
Okay, so these are PBI
Two.
2s. Why not PB pluses and I minuses?
Because they came together, they didn't go apart.
Because they're stuck together. Are they stuck together? Yeah. Are they staying together? Yeah. That's a precipitate. Remember back in the paragraph you wrote at the beginning of this class, the very beginning, we said if it's insoluble, we write it as a ionic compound solid. Ionic compound solid stays together. Okay? And what about this compound? It's going to dissociate into K pluses and NO3 minuses. Everybody okay with that? So the first thing dissociated, the second thing dissociated, this third thing, this product, stays together, and this last one dissociates.
Why? Why would that dissociate and why would that
Because this is soluble, this is insoluble. Okay? Everybody okay?
Yep.
Okay. Now, is anything, there's two things happening right now. One is an actual game, and there are players in that game, and there's a product in that game. And the second thing are there spectators. People just watching everything happening. Can you pick out, in our picture, who are the spectators, and who's actually playing the game?
PBI is expected.
PB and I, really? They haven't changed?
No, they're playing.
They're playing,
They're playing. They're scoring goals.
right? They're playing. Something has happened to them. They have changed. Who just showed up, ate some popcorn, and left?
K and I.
K and I. K plus and I plus have just spectated. They've just watched. They've watched those ions happening. The K plus is here and the K plus is here. He hasn't changed at all. He's going home. Perhaps a bit happier, perhaps a bit sad if his team won or lost. But he hasn't played. He's just spectated. Who are the actual players? It's the PB, 2 plus, and the I minus making this PBI. They've played. So thinking of this in algebra, notice I've got a big equation here right now. I've got PB2 plus NO3 minus plus a K plus an I plus, and they all came together and they made this compound, which is a solid, and that ion and that ion. You know in algebra where you've got an X on the left and an X on the right, you can cancel them out? Same thing here. See how I've got a K plus on the left and a K plus on the right? It's there when I start, and it's there when I end. It hasn't changed. It's spectating. Anything else starting and ending the same way?
I don't agree.
Starting, ending the same way, unchanged. And so what's actually happened, the PB2 plus and the I minus went to PBI2. That's actually what's happening. And these guys are my spectator ions. Okay? So the normal science 10 kind of experiment is called a non-ionic. All of these broken up into the dissociation equation, or it's held together if it doesn't dissociate, like it's a molecular compound, or it's an insoluble compound. This is called full ionic. Okay? And then this, what's actually happening, is called my net ionic. That's what's actually happening, the net. It's taking rid of. So actually, do you know what? When I went into the back room and I got this potassium iodide, I could have got sodium iodide, calcium iodide. Wouldn't have mattered because I knew that the potassium would just be spectating. So whether I bring potassium to the game or sodium to the game, or doesn't matter, they're just going to sit in the bleachers and eat popcorn. Doesn't matter who I bring to the game. The iodide though mattered to me, right? Because I knew iodide would be forming. So that mattered. Does that make sense? Okay, so on your sheets, on these sheets down here that I've just handed out to you, let's do number 1 together. So the reaction of hydrochloric acid with sodium hydroxide. Welcome to Science 10. How do we write this as a reaction?
I miss it.
It was hard when you were there. Now it's easy. Guess what it's going to be like when you're in Chem 30? You're like, I miss Chem 20. It was so easy. And in university, you're going to think, I miss Chem 30. It was so easy. Yeah. It always gets harder. It's called life. Don't see that. Okay. How would I write this? Science 10. The reaction of hydrochloric acid with potassium hydroxide. HCl. Oop. Ooh, again. HCl plus KOH. And what do I get? HOH or H2O and KCl. Yeah, you can write whatever. You can write either one. Whichever one would naturally. Okay? What is the full ionic equation? What's the full ionic equation? How does HCl exist in solution? H. Come on, everybody. Come on. Wake up. You got 15 minutes
plus.
class. H plus and
Cl.
and Cl minuses. States on those? Aqueous. Aqueous. How does KOH exist in solution? Zach.
K plus and OH.
Good. Everybody see that these came from that, these came from that. Everybody okay? All right, so KCl, how does KCl exist in solution? Yes, it's soluble. Spencer, McCarty.
K plus aqueous plus Cl minus aqueous.
Good. And how does water exist in solution? Jordan? How does water exist in solution? That's right, because it's a molecular compound, which is polar, yeah. So it stays as H2O liquid. It's a molecular compound. This goes back to the beginning of the lesson, that big paragraph. Molecular compounds stay together. They don't dissociate. Everybody say that. Molecular compounds stay together.
Molecular compounds stay together.
They don't dissociate.
Dissociate.
I'll bet money that 3 of you are still going to write a dissociation on a molecular compound on your test. All right, so do we see anything that's just spectating? It's the same at the beginning and it's the same at the end. It remains unchanged. K plus spectating? Yes?
Of course.
Anything else spectating?
Cl.
Cl minuses. Oh, by the way, I forgot to actually verbalize this, but just make sure your beginning equation is balanced like Science 10 as well. Okay? It should be balanced at the top, which it is. That's why I didn't actually say it.
It's not
Okay.
a true compound.
Okay, so the net ionic then, after I've canceled those things out,
They don't dissociate.
I'm left with H plus aqueous and OH minus aqueous And in this neutralization equation, I've taken care of all my H pluses and all my O minuses, and I end up with, that's not what I meant to write, HOH for water. See that? And the spectator ions were Cl minus and K plus. Got it?
Yeah.
Can you do question 2 on your own? Do you know what I must say? I think the concept that students find the hardest on this one is the science 10 stuff. You just don't know your equations well enough. Okay? So I really need you to concentrate on that, because if you don't have that bit, then you're kind of messed.
Yeah.
So it's really important that we concentrate on making sure we know those. So scrolling down a little bit, it's going to disappear. Let me just get you started on question 2. The precipitation,
Dissociates.
Excuse me, boys.
I believe that's for me to say. The precipitation of silver iodide from a reaction between silver nitrate and potassium iodide. What's the reaction? What's the reaction, Isaiah? Sorry, I just can't hear you.
Double replacement.
It is a double replacement. What do I need to write down?
Silver iodide.
Okay, so that looks like this, AgI. Okay, hold on a minute. Hold on a minute. Precipitation of from the reaction between. So what do we start with, actually?
Potassium iodide.
Silver nitrate.
We start with silver nitrate and potassium iodide reacting together to form that silver iodide. You see that? So I'm going to actually start with silver nitrate and potassium iodide, and I'm going to form silver iodide. And what? If it's a double replacement,
Can.
K and O3. And I'm actually going to make sure I put my solid there for that precipitate, so I remember to keep it together. And the rest are
Aqueous.
aqueous.
So on the one before this,
Mm-hmm.
they were all aqueous, but the other one was liquid, so that's the precipitate.
It's not by
Just as
definition,
a
a
solid.
precipitate is a solid that's formed from two solutions.
But
So, but we still keep it together because it's a molecular compound.
and it does not dissociate.
Right.
That's right.
And but precipitates do not dissociate as well. So you're right. You
Yeah,
think of
just-
them as the same kind of thing.
Okay.
Okay. So now I've started you. You guys do the rest.
Yeah.
And work really hard for 10 minutes. You won't have any homework.
Is it just this question?
No, keep going. Question 3 is maybe the